This is Learning Assessment Problem 713. The problem-solving strategy here is to consider this second-order transient circuit, which is a series RLC circuit, and determine the response exhibited by this circuit. In other words, determine the damping condition in the circuit. We are given values of resistance 2 ohms, the inductor is 1 Henry, and we have 3 different values considered for the capacitance. If we were to write a loop equation with respect to the current I of t in this circuit, we would obtain the differential equation d squared I dt squared plus r over L di dt plus I over LC is equal to 0. This results after doing a differentiation of the original loop equation to remove an integral. Now the characteristic equation for this situation would look like s squared plus 2 zeta omega naught s plus omega naught squared is equal to 0. Here the omega naught is the undamped natural frequency and the zeta term is called the damping ratio. So we have a comparison here that the omega naught squared is equal to 1 over LC in our circuit, and likewise for the zeta we have that is equal to R divided by 2 omega naught L. So the omega naught contains the capacitance value, and therefore the undamped natural frequency omega naught and the zeta term both are functions of capacitance. So for the part A of this problem, the capacitance is equal to 1/2 farad, and this gives us that the omega naught squared is equal to 1 over 1 Henry times 1/2 farad, which is equal to 2, which gives us that omega naught is equal to the square root of 2. Then we can calculate the damping ratio. Zeta is equal to R, which is 2 ohms divided by 2 times square root of 2 times the inductance value 1 Henry. So this is equal to 1 over the square root of 2, or the zeta term is equal to 0.707. This is less than unity. Therefore, for that capacitance value, we have an underdamped circuit response. Part B of the question, the capacitance value is equal to 1 farad. This gives us the omega naught squared is equal to 1 over 1 Henry times 1 farad. And this is equal to 1, which gives us that omega naught is also equal to 1. That's radians per second. Now we can calculate the zeta again is equal to 2 ohms divided by 2 times 1 radian per second for the omega naught times 1 Henry, and this is equal to 1. So zeta is equal to 1. Then we can calculate the zeta value for this circuit. We have that is equal to R divided by 2 omega naught L. This is equal to 2 ohms divided by 2 times 1 radian per second times 1 Henry, or the zeta is equal to unity in this case, and therefore the circuit is critically damped. Part C of the circuit problem. For part C, the capacitance is equal to 1 farad. For part C, the capacitance is equal to 2 farads. And this will give us that omega naught squared is equal to 1 over 1 Henry times 2 farads is equal to 1/2, which gives us that omega naught is equal to 0.707 radians per second. And we calculate the damping ratio zeta is equal to 2 ohms divided by 2 times 0.707 radians per second times 1 Henry, or zeta now is equal to 1.414, which is greater than unity, and we can say that the circuit response would be over damped.